This example is starting us off with a graph, and then it's telling us in the language that the points down here make up the vertices of a rectangle. And they kind of draw out that little rectangle for us right there. And so that rectangle, they want us to know for what value of x does that rectangle have a maximum area. And so when you see maximum in a problem, that kind of tells you that you should be looking to do a first derivative test on it. Anytime I see the words local max, local min, intervals of increasing or decreasing, it tells me that I want to run a first derivative test. Well, in order to do that, I need to be able to find what function is it that I'm actually going to be running a first derivative test on. Well, we're trying to find the maximum area of a rectangle. So we start off and we say to ourselves, okay, I know that the area of a rectangle is going to be equal to the base times the height. And so from that picture, I need a formula for my base and I need a formula for my height. So I come over here and I look at for the base first. Well, I see that I'm starting here at 2, and this base is going to go all the way over until I run into whatever the x value is over here. So there's two thoughts on this. One would be, okay, is that going to be 2 plus x? Is that how I find that gap in between those two things? Or instead, am I looking at an x minus 2 to get my base out of there? Well, I kind of, when I'm doing these and trying to figure this out, I come through and I kind of give myself a value for what x might be. So I say to myself, okay, well, if x is 5, then I know the gap in between those two things, that base in that situation would have to equal 3. That's the distance between 2 and my number 5 that I plugged in there. Well, what you'll notice is if I come to this top one and I tried to plug in 5, I would end up getting out 7. Because what that first one is saying is include all this extra space that makes up 2 plus everything else after it here. And that's more than what I want. What I really want out of here is to take 5 and subtract off 2. That's going to give me my base because I don't want all the stuff before 2. I want to start at 2 and I want everything in between 2 and whatever my x is. So my base formula on this is going to be x minus 2. Then when I come to look at the height on most calculus problems is going to come from taking whatever that x value is and plugging it into the equation, because that's going to give me this y value here. That's going to give me my height. Well, this formula is f of x equals 1 over x squared. They're telling me whenever I plug in x, the y value that I get out of there is 1 over x squared. So my height formula on this is going to be 1 over x squared. So now I have an area formula to work from. So now that I've got my formula to work from, now I start running through the steps of the first derivative test. So step 1 of the first derivative is going to be to find f prime of x, find my derivative. Well, you can always save yourself a little bit of trouble if you stop for a moment and say, is there any way that I could possibly clean this up? Because looking at it right now, this would be a product rule. And you could do it as a product rule if you see it. But I oftentimes, if I can multiply the two things together ahead of time, it's going to probably push this into a power rule, which is a much more straightforward derivative, and then usually going to be a much more straightforward algebra problem after that. So if I distribute this 1 over x squared into here, I end up with a formula, x times 1 over x squared. The x on top here would cancel out one of the x's on bottom, and I would be left with 1 over x. Then multiplying negative 2 by 1 over x squared, I would get negative 2 over x squared. So there's my starting equation, and now I need to find the derivative of it. Well, looking at that, what I first also need to do is look for rewrites. So remember, before you go rushing straight in to take a derivative, you want to look to simplify it, and you want to look to see if you've got any rewrites. And what we're looking at here is one of the classic rewrites we have to always be on the lookout for. Whenever I have a number over x to a power, I need to rewrite that by bringing the x up from the bottom to the top and making that power negative. So if I had something like 5 over x to the third, I would want to rewrite that as 5x to the negative 3. So My rewrite on this, there's an unwritten 1 on the bottom on that x, so I rewrite that. I've got the 1 on top and then x to the negative 1. And then on the bottom, on the second one, I've got a 2. So I have the 2 that was already on top, and then I bring up the 2 from the bottom and make it negative. So there is my rewrite. Now I'm ready to go apply my power rule and get a derivative out of this thing. So then a prime here, following the power rule, which says bring the power down and then subtract 1 from the power. I bring the negative 1 down. Negative 1 times negative 1 gets me negative 1. X, and then subtracting 1 from the power gets me a negative 2. Careful on those negatives. Sometimes you can go too quick and go the wrong direction in your head. So then on the next one, I do the same process, bring the power down. Negative 2 times negative 2 is going to get me a positive 4x, and then subtracting 1 from the power is going to get me a negative 3. So step 1 of my first derivative test process complete. Now on to step 2. I need to find my critical values. So critical values occur when two things happen. They occur when my first derivative equals 0 or when my first derivative is undefined. And I always have to worry about that undefined situation whenever I've got a fraction and I have to concern myself with where I would get division by 0. So coming into step 2, we also want to be on the lookout for undoing rewrites. I'm going to set this equal to 0, and as I do it, I always tell people negative exponents are great for doing calculus. They are horrible for doing algebra. So we need to undo those rewrites so that we can do some algebra on it. And essentially what's happening is we're going to undo the rewrite we just did. We're going to take that negative power and we're going to push our x back down to the bottom. So on this first one, I get negative 1. I put that x back down to the bottom, and that's going to get me x squared. Plus, I have the 4 still on top, and then pushing that x to the negative 3 back down to the bottom, I get 4 over x to the third. So again, that's just a rewrite as we come through here. What that allows me to see now is I do have to be careful for that second situation, that undefined situation, because I have fractions. I could get division by 0. I could have zeros on the bottom here, and that would get me an undefined critical value. So I know that this would be undefined whenever x equals 0. Good news is, though, keep track of any sort of information they tell you about where x lives. So they told us that x had to be greater than or equal to 2. Well, x equals 0 doesn't fit that, so I can actually throw that out as an option right now. You have to be prepared for it, but you also have to make sure that it fits whatever the domain is of your given problem. So don't have that as a critical value, and so I keep coming through my work here, and I'm going to keep doing my algebra to solve for x. So the first thing I'll do is just add this 1 over x squared to the other side. Whenever I can make things positive, it usually makes my algebra a lot easier. So I add that to the other side, and then I get 4 over x to the third. Now what you're looking at is a classic cross multiply game. Whenever you've got two fractions set equal to each other, the easiest way to get through that algebra is to just cross multiply. So I end up with 4x squared, 4 times x squared equals 1 times x cubed equals x cubed. Now the next algebra move you're always looking out for is anytime you've got a power of 2 or greater going on with your x's, you want to get this set equal to 0 so that you can factor it. So I'm now going to set this equal to 0 by minusing the 4x squared over to the other side. I get 0 equals x cubed minus 4x squared. So I've got it set equal to 0, and now I look to factor. And what I can see is I can pull an x squared out of both of these pieces. So I pull my x squared to the front. That's going to leave me with just an x from the front here, minus, and then I pulled the x square out, so that's going to leave me with a 4. The reason we do that is now that these two things are being multiplied, I can set both of those equal to 0 and solve those two little problems to find my critical values. On the left-hand side, you can see that I will square root both sides, and I end up finding that x equals 0 again, which I already know isn't in my domain, so I can throw it out. The second one, I add 4, add 4, and I end up with x equals 4. So there is my critical value, and I can feel pretty confident that that's going to be where my max is happening. But if you want to make sure that what you found is actually a max and not a min or not neither, then you got to go through step 3 of your first derivative test. You need to actually do the first derivative test. And that's where you would do what I call the number line game. So we're going to come over here, we're going to draw out a number line for ourselves, and we're going to mark our critical value on there. So I've got my critical value happening right here at 4. Then we need to choose test values on either side of that critical value. So I'm going to choose something to the left, remembering that it's got to be greater than or equal to 2. So I'm going to choose 3 for a test value. And then on the right-hand side here, I'm going to choose 5 for a test value. Remember that this is a first derivative test. So we test those values in our first derivative, right? So we want to find a prime of 3, and we want to find a prime of 5. The easier way to handle that derivative, right, is again to think about it in its rewritten form. So instead of having those as negative exponents, I would want to think about this a prime is equal to negative 1 over x squared plus 4 over x to the third. So I come in and I plug it into my first derivative here, and I get negative 1 over 3 squared plus 4 over 3 to the third. And that's going to end up giving me out here, I'm going to get negative 1 over 9 plus 4 over 27. To compare those, I need to find a common denominator. So my common denominator would be that 27. So I go ahead and multiply on the top and the bottom on this left one, and I get negative 3 over 27 plus 4 over 27. That gets me 1 over 27. I don't really care about the number, right? I just care that that is positive and therefore increasing coming into that critical value. And now we're going to do the same thing with 5 here. We're going to go ahead and plug 5 into our derivative and see what we get out. So we'll get negative 1 over 5 squared plus 4 over 5 to the third. So in this situation, I end up with negative 1 over 25 plus 4 over 125. My new common denominator would be that 125. To get it on this other side, I multiply by 5 over 5. So I end up with negative 5 over 125 plus 4 over 125. I end up in the end there with negative 1 over 125. So I don't care about the number, I just care that this was negative, and that tells me that my graph is decreasing coming out of there. Once I do that, now I can see the shape of what my graph was, and I can see very, very clearly that what I'm actually looking at was the max that I was trying to find. So we found out that at x equals 4, our rectangle would have a max. We look over, we find our answer, option C, x equals 4. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.